guys, I'm Chris Boden, and you're not. Welcome to the Geek Group, where we're here today with freaking Dan Eakin. Maglinvin. Is that it?
Maglinvin, you got it right.
That's right?
You got it right.
It only took us like 8 videos. I finally got it. So, welcome. You're bringing your toys.
I did bring my toys.
It's cute.
It's tiny. Not a problem with compensation.
So what do you got here? It's a clock.
It is a clock. It doesn't look like a clock, but it is in fact keeping time like a clock should. You can see there's a blinking LED in the upper left corner.
Yeah,
and
that's the UV one, which is great on camera.
Oh yeah. I didn't have a blue one, and it's close to blue, so I went with it.
It's so cute.
It's really hard to look at for an extended period of time when it's turned on and stays on.
That's all right. 90% of the planet can't read it anyway. So
right.
What is this? It's a binary clock?
It's a binary clock. It reads in binary. Your hours are across the top in green. Your minutes are across the bottom in red. It reads right to left. Currently, the time is now in binary 1, 2, 4, 8. So we are at 10 minutes. This clock's been running 10 minutes since I reset it. Just before we started shooting the video, actually.
Now, should we take a minute and teach people how to count in binary?
We probably should.
Okay, here, we'll go to the whiteboard. Follow us, cameraman, to the whiteboard. I'll give a quick lesson in binary, if I can find my markers. Okay, now, I know Craig says that you're supposed to do this the other way, but...
I believe you. I side with you. You do it right to left when you're adding it together.
That's how I've always been taught.
But when you look at the wristwatches that they sell online, it actually reads the other direction on a wristwatch. The 1 is on this side as opposed to this side. I'm dead serious. The $200 binary
I've always
wristwatch.
done it right to left. So it's 1, 2, 4, 8, 16, 3, 2, like that. That's how I've always learned it.
Yes.
But the wristwatches are backwards.
No, that's the way the wristwatch reads.
Okay.
But when you're doing the math, don't you do it right to left? Obviously, we're confused.
This is left. Left and right.
Yes.
Okay, here we'll help you out. Left.
That might not be a bad idea, actually.
Okay. Now this is how I learned binary. I could be wrong. It happens with ferocious regularity. But this is how I learned.
I bow to your wisdom.
Okay. You have your 1 spot.
Yes.
Your 2 spot.
Correct.
And then you just keep doubling. 4, 8, 16, 32, 64. That's all we need.
Well, yeah, actually, we only go up to 32 for minutes, so we don't need the 64.
So we'll stop at 32. Now, this is how I learned binary. Okay?
All right.
And follow along for those at home. This is how it's done. Now, you've got a bunch of lights. Because, see, computers are stupid, which is really handy. Computers can only understand if something's on or off. It's how transistors work. Okay, either the light is on or the light is off. The switch is up or down, on or off, true or false, 1 or 0.
Correct.
And that's where we get binary. Everything in binary breaks down to 1 or 0. So how do you make big numbers in binary with just a 1 or a 0? Now, here's how it's done. If you have 1, then you have 1. If you want 2, you have 1, 0. Because when you count, you're used to things like in normal base 10 math, that's a 1, that's 10, that's 100, that's 1,000, and the place is multiples of 10, right? So this is base 10 math. Well, this is base 2 math. So the places are multiples of 2. So in binary, you would have, if you want the number 1, you just have 1. If you want to count to 2, it's 1, 0. Now here's where it gets cool. If you want to count to 3, it's 1, 1. Because this is the 1 spot and this is the 2 spot, and 2 plus 1 is 3. So 1, 1 in binary is 3. This is where, for all of you out there who have never gotten the joke about there are 10 types of people, those who understand binary and those who don't, well, that's because this is the 2 spot, so 10 in binary is the number 2. Now, if you want to count to 3, you've got 1, 1. If you want to count to 4, you go 1, 0, 0. So it would look like 100 to the rest of the world, but it's actually 4 in binary because everything else is 0 and there's a 1. Now, you can have leading zeros as well. Like if you're dealing with computers where they're used to, let's say, bytes. So we've got 8 bits.
Right.
I'm gonna add us so that we can have 8 bits. I'm going to add, because we've got 1, 2, 3, 4, 5, 6, 7, 8. We need that. So we'll add 64 and 128.
Correct.
Okay. Now, with this, you've got, it's all zeros. So you have leading zeros because the 0 or 1, the single 0 or 1 is 1 bit of information. A bit is 0 or 1, on or off, true or false, binary.
Correct.
To have a byte, which is B-Y-T-E, that's 8 bits. Okay? So that gives us all the way up to 128. Now, this will let us count a lot higher than 128 because we can take 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And if I'm doing my math right, that should give us 256.
I have no clue.
I
But
think so.
yeah, something like that.
255, 256, one of those. So, yeah. This is, now you'll notice, for those of you that have been around computers for a while, you'll notice these are the memory sizes. You ever notice whenever you buy memory sticks, they're always like 8 meg, 16 meg, 32 meg, 64 meg, 128 meg, same as gigabytes on like memory cards nowadays.
That's right.
If you buy memory cards for your video cameras and stuff, our cameras run on 16 gig cards. The next size card will be 32 gigs. You will not see an 18 gigabyte memory card. Just doesn't happen. It's always 16 or 32 because they're based on binary math, and that's how we go. So let's say we want to count to 5, okay? Because we've got our 1, and then 2, and then 3, and then 4. Now if we want 5, we take the 4 and we add our 1 back. So every odd number will end in 1.
That's right.
Okay? So that's our 5. Now if we want to go 6, we set that back to a 0. We add our 2. Now that's 6, 1, 1, 0. So 6 in, with 8 bits is 0, 0, 0, 0, 0, 1, 1, 0. And that's 6 because it's 4 plus 2. 7, 1, 1, 1. Now if we go to 8, we just erase all those. 1, 0, 0, 0. That's 8 because we just take 1 out of the 8 row. And that's how it works. And you just see, it's maddening at first. It'll make you crazy. But once you get it going, it's really easy. Yeah. And once you learn the basics of binary math, you can read things like that clock. Because it just makes sense. It's just learning the places. It's really easy. And it's just counting by 2. It's 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. Yeah. We could do this all day.
We could.
In fact, it's kind of like a geek pissing contest to see how high you can go just in your head.
Yeah.
Yeah. But yeah, that's the basics of binary. It's all about 2s. So now you know. And with this, you can make, you need 8 bits to make a byte, and the reason a byte is important is it takes a byte to make a letter or a number. Like if you want to have A in binary, it's some combination of 8 bits, and you can make an A or a B or a C or whatever. Anything in the ASCII alphabet you can make out of 8 bits. So this is where terms like megabyte and gigabyte and all that come from. Megabyte is 1,000,000 bytes, but it's 1,000,000 base 2, so it isn't exactly 1,000,000 bytes before everybody writes in. It's some obscure number. That's why the hard drives and stuff, when you get like a terabyte hard drive, it's only actually like 800 and change gigs.
Yes.
Because of the difference between the marketing guys and the real world. When you see, you've just bought your terabyte hard drive, but you take it home and it's formatted and it's only like 800 gigs, well, you stepped in the marketing, because the marketing guys use base 10 math, which doesn't quite even out to base 2 math. So in base 10, a kilobyte is 1,000 bytes. But in base 2 math, it's actually 1,024 bytes.
Yep.
So because that's where you come out to. So it's sometimes a little up, sometimes a little down, it's a little different. Hey, confused, but yeah. All right, so now we know how binary works.
That's right.
There's an Arduino here somewhere. I can just feel it coming. It's not. You
Blood
can't have. You can't have.
We hide it. We're ashamed of ourselves.
Oh man! For those of you that don't get the joke, go here. It's an XKCD thing. But yeah, we have an Arduino in here for blog cred. you can't, for reasons I don't really understand, you cannot have a little pocket electronics project in
Without an Arduino.
this decade without an Arduino in it. It's everywhere.
They're so easy to work with.
Yeah, that's what it is.
It's dumb easy.
Okay.
You don't have to know assembler or any of those old languages to program a microprocessor.
Let's talk about the Arduino. Let's talk about what you got here. Let's break it down for people and show them how they can build this at home. Now, did you do this on your own, or did you do this with schematics that you downloaded somewhere?
I played with this on a breadboard until I came up with a design I liked.
So you did this totally on your own?
Yes.
Do you have schematics for it?
No, I kind of just kept going until it worked.
No schematics at all. Could you write some schematics?
Yes, I could. Absolutely.
Okay.
It's really quite simple, actually.
Okay, because what I'm thinking is if you could write some schematics for this, and if you could copy your code and all that, we can put this in the show notes. We could put this on the website, and people could see this so that they could make a binary clock on an Arduino.
Mm-hmm.
And that'd be cool.
That would be awesome.
There you go. Okay, so can I unplug this?
Yeah, absolutely.
All right. I don't want to
No,
make it
it'll
angry
just turn it off. Well, actually, the 9 volt's hooked up, so it'll keep going.
I just don't want to freak out or anything.
No, it won't.
So I'm gonna turn this around. That's our Arduino.
Yes.
And what does it say?
A Duminlov.
Duminlov?
Duminlov. I don't know. It's Italian something. If you turn
So
it
it's
over,
probably like Duminlove or something.
yeah. If you turn it over,
Oh look, there's Italy.
so
About that?
I don't know what it
It's
means.
upside down, but it's Italy. See, look, there's Italy on the bottom of an Arduino. So all right, so we've got an Arduino. Now, for those that don't know, an Arduino is pretty much, it's a little chip package thing that every electronics geek in the world is playing with right now. It's basically a generic platform that lets you do stuff.
Yes, correct.
Okay, so
Anything.
what did you do here to this, or is this out of the box? This is how it comes.
Out of the box. I ordered that from Hong Kong. You can get them locally if you wanted to, but you pay a little bit more money for them. eBay is wonderful for all Arduino projects if you got a little bit of time.
What is the Arduino? What can you do with this?
Okay, this is the Atmega chip, and that's actually the heart of the Arduino. And then you got your
Now that's the big thing right here.
Yep,
Okay.
yep. And then you got your clock down here that gives it a pace, so it has timekeeping capabilities. You have your reset button here, which doesn't do much without
Just
anything
reboots
hooked up to it. Yeah, it just starts it on 0.
Okay.
You have your ICSP headers over here, which allows you to do some old school.
ICSP?
It allows you to interface with the chip and program it in an old school way. I don't understand it. I don't want to understand
assembler or
it.
something, or what?
That's what I understand. I started to read it and I got a headache. I stopped because mine hooks up with USB. I don't have to play with it.
And it just works?
It just works.
All right.
You install the software. It goes hardware found.
And it runs off a 9-volt battery?
Yeah. You can hook the voltage of this thing can handle anything between 5 and 12 volts. So you can
That's handy.
It's got a little voltage converter down here. It runs on 5 volts, but you can hook it up. It can handle anything up to 12 volts. So actually you can deploy this into your car and you can do really goofy things with automotive tech really, really fast.
Cool.
Actually that's my intention. The reason I got into it in the first place is because I have an older car that doesn't have one of those computers in it that allows you to, yeah, exactly.
Okay.
And
do you have like ODB1 or are you pre-ODB1?
It's 1971 German
you're screwed.
made.
Yeah, that's way before ODB.
I have to invent sensors so that I can get information from the engine so I can print it onto
So you're going to be like mounting Hall effect sensors on the engine block and stuff like
yes,
that.
Yes, exactly.
Nightmare. Oh man. What kind of car do you have?
It's a 1971 Opel GT. It's a German.
Really?
Spoots.
You got an Opel?
Yes, I do. It's poor man's vet. I love it.
Oh yeah. I'm just trying to figure out how you shoehorn you into an Opel.
You remember Joel, the accordion guy?
Yeah.
We used to go cruising all the time, but you
have to in an Opel.
You have to roll down the windows.
Because you both won't fit in the car.
I've thought about just cutting the top off so we have a little bit more room, but they're unibodies, so it's usually a dangerous idea.
Yeah, don't cut the top off an Opel. They're
yeah.
And do you got one with the flip headlights?
Oh yeah, absolutely.
Oh yeah. Man, I haven't
it's
seen
a
Opel
family
in
thing. My
years.
dad carved his headlights out and he mounted them underneath, and it's all streamlined. There's
That's
no door
so
handles,
cool.
all that jazz.
Hey, you need to bring this over. Like we get a new lab here in GR. You got to bring it over, and we'll put it on the lift here.
I have to actually, because the
engine.
engine's out of it. I rounded off the cam for the exhaust over number 2.
Okay.
So the engine's out of it, and I got so fed up with the car, just a little bit here and a little bit there breaking down, that it has. I mean, it's a body on axles right now, and I'm slowly.
Huge fun.
Oh my goodness.
All right, so
workload.
let's talk about the clock, because man, I can sit here and talk about Nopal GT all day. That's
but the idea is to use the Arduino as an interface to the car, so I can put my laptop next to me and know just what that engine is doing. That's the reason I got into it.
Okay. And this is a project to learn how to use the Arduino and how they work and all that stuff. Okay.
I'm not. I go to school for computer IT. Binary. I learned stuff about binary just now. So.
Well, I'm glad I can help. It's such an advanced programming class here.
It drives me nuts because I actually had the lights counting in the right direction, and I reversed them because I was confused.
Because you didn't know.
Yeah.
Well, I'm happy to help, man.
Yeah. So when we look at it, though, it's going to count 1, 2, 3 instead of 1, 2.
Well, we'll fix that, and do you want to take a minute and we can come back?
Yeah, let's take 5 minutes and.
Okay.
Yeah.
We'll be back after this quick message. Hey there guys, we're here with Billy where we're going to take a minute and teach you about ratchet strippers. Now a lot of the guys out there are stripping wires with like a Swiss Army knife or something like that. You can do it with your Gerber. There's old style strippers like these with the rings, but these suck. What you want to get if you're doing serious electronics works is pick up a pair of these. These are ratchet strippers. And there's a lever mechanism internally where when this handle moves down, it closes the jaws there. And when this handle moves down, it closes the clamp here with those jaws. So when they both squeeze, you put a wire in there, and when they both squeeze down, it actually slices the insulation off, and this side holds the wire and pulls it apart. It comes right off just like that, and then snaps back together. So that is ratchet strippers. Today's tool of the video, tool of the week, whatever. This is our featured tool video thing here. Ratchet strippers. You need to get a pair. They're great. Have fun. All right, we're back, and now it's going in the right direction.
It's going in the right direction. We can see that by holding the button down. Now it reads from the other
Yay! Here. They can't see you. You got it right spot for the camera then. There. So that's minutes.
Yes, that's in minutes.
Okay.
And the middle one's in hours.
And this is the green is the hours.
Yep.
What's the other button do?
I want to add an alarm clock function to it. And that will be that switch.
Oh, okay. Yeah, I noticed there's no speaker on this.
No.
It had the little speaker in your other videos.
Yeah, no, I had written a tone program for the speaker, but I hadn't moved it over into the clock software yet.
Okay.
So it was there for testing, but.
What do we got?
Okay, so we have the UV light counting off seconds, the green light's counting off hours, the red light's counting off minutes. It's all in binary. The 3 buttons here. The first one does nothing right now. It's hooked up, but it doesn't actually have
reserved for future use.
Exactly, place reserve. Middle button is hours. Last button is minutes. And when you hold the button down, it'll advance 5 times a second. So if you just hold it down,
which is about
which is to say you exactly have 200 milliseconds to let go of it if you only want to advance it once. Which is
you gotta take the next step on it where like when you do the clock like on a stove or something, you hold it down and the first 5 seconds count off slow and then it goes now we actually did a little hack on this while we were in the break and we added a lerf. Can I just pull this off?
Yeah, it'll just
I didn't
shimmy off.
I didn't want to like break it or something. We added a lerf right here. I have no idea what this is off of. It's been sitting on the kitchen counter for like a week and I just keep fidgeting with it. But we added a lerf here because he's got the grounded top was touching his solder blob system.
Here, on this side.
Over here? Okay.
Yeah, this switch is checked for low.
This isn't a wire here. You actually just have a solder blob.
Yeah.
That's...
I told you I was an amateur. I wasn't lying.
It's so ghetto.
I know. It's so awesome. It's my signature.
That's your signature solder blob?
That's my signature.
Okay, right here. This is Dan Eakin and his signature solder blob.
Everything you see me ever work on, I'll have one of those because my dad actually has a board etching tool, and I've never learned how to use it. Can I plug that back in, or do I got to shut down? Yeah,
okay. I don't know how delicate they are, so I'm really scared. I'm used to stuff where you have to power everything down to unplug it or stuff like that. And this, just crank it together, man. Just So, it's great. It's so cool. So yeah, that's your clock.
That is real simple. The code is real simple. To start it off, you have to tell the Arduino what pins are hooked up to what things, and usually you give them a
is it like
real
a
world
name
thing? Oh, actually, it's.
I don't know if we've never tried this, but let's see if we can fake it. Let's see if we can. I'm going to unplug your power. Do you have enough battery?
Yeah, it
right.
should be.
Let's see. No, it won't go back far enough. Ghetto screen capture. All right, so there's
there's a snippet of the code, and you can see here that I've made an array for the minutes and the hours pins, and we got some mathematical array or variables for the calculating the hours. The second LED is pin 19. I don't know. I can't read it on the block. Yeah, it's pin 19. The minute, the hour button, the set button. You can actually see the buzzer's actually in the code. It's just I haven't worked out how to.
Now, what is the code? What type of code are we using?
To me, it reads like PHP, and I think it's C. I'm pretty sure that's what
I have no idea.
That's what they call it.
One, so I don't know.
It's real simple. Int hours semicolon, and you've just assigned the hours variable as an int, and you're done. I mean, it's really not complicated.
Okay.
It reads like a book to me, but I couldn't tell you why or how because I'm all self-taught.
Okay. Well, I'm sure that about 5 minutes after this airs, there's going to be no less than 1,000 people commenting, telling you exactly what it's coded in and how and why. And all
that'd be awesome because I can't get a straight answer.
I'm sure it's not hard to find out because it's something that everybody's playing with right now. The Arduinos are super popular. So it's something everybody knows, and everybody's going to know what the code is. And
there's libraries of information. Instructables.com has an Arduino competition, and they usually make all their code and all their hardware and all the schematics open source. And the actual mathematical function that tells me what light to light up, I yoinked from another guy's project because I couldn't figure out how to take a value like 17 and turn it into a series of binary information for the lights. So I had to yoink somebody's code in order to do that because I don't understand it.
Well, that's what I like is you're totally self-taught on it. So the downside is you've got some holes in your knowledge, but you're doing this and knowing nothing, totally off the couch, you're able to figure this out and build a binary clock, and it's cool.
Honest to God, this is the second thing I've ever soldered together in my life.
Okay, so you're total virgin to this pretty much. Now, how much did this cost? Like everything.
I went and bought the lights at Radio Shack, and that was a bad idea because they were expensive. You could have bought them off eBay and got 100 of those little LEDs.
I just bought 200 of them for the water clock project that we're doing.
Yeah, absolutely. And I'm looking forward to that myself. The switches are actually still out of. I learned how to solder by desoldering.
What'd you take them out of?
Those are actually out of an old coffee maker.
Really?
Yeah.
Oh, that's so cool.
Yep. So it's got.
The resistors are store bought, so those are new.
Actually, they came with the LEDs.
When you bought the bulk order?
Yeah, the bulk. They sent a whole bunch of resistors. If you're trying to drive the LED off 5 volts, you use the one. If you're trying to drive it off 12, you use the other. Okay. So
and they'll run naturally off like 3 or something.
Yeah, I think it's 3 volts.
All right. Now the Arduino comes. It comes with all that right there.
Yeah.
Like so that's how it comes.
Yeah, no, none of this.
None of this.
Yeah.
But that's what you get. And it comes with the chip and there's a button already under. So this is ready to go pretty much. You just figure out the spacing for pins and you're set.
Well, you can
and then this you got at Radio Shack, the board.
Yeah, it's a $1.99 for the board and some wrap wire. Yeah.
So this whole how much is this? How much is an Arduino?
I bought it for $28 free shipping from a guy in Hong Kong.
Okay. And that's complete.
Yep.
Are there different Arduino boards?
There are. There's a lot of different boards. There's a larger version of this. They call it a Mega, and this has actually got 6 pulse width modulation pins on it. Okay. The Mega has 14, and instead of only having 13 digital pins, it has 54. So you can hook up a whole bunch of stuff to it. The problem with the Mega is you buy it locally for around $70, or you can get it overseas for around $50.
Now I see pins on here like TX, RX. What is it? Serial data?
That's so you can link a whole bunch of Arduinos together, or you can run them to a Wi-Fi solution or an Ethernet.
Okay. Now
you
down
can
here
actually build a web server on one of these.
Reset, 5 volt, 3 volt, ground. Volt in.
Yeah. There's 2 ground pins on that rail.
Okay. And what is this power to here?
Yeah, this is 5 volts.
And this is your analog in.
Yep.
And so these are your digital side.
And incidentally, you can actually make the analog in pins digital pins as well. So it's just the way you declare it in the code. There's a phrase called pin mode, and these are numbered 0 through 5. But when you want to use them as digital pins, you got to use 14 through 19.
Okay.
In order.
You've got 13 over here.
Yeah, exactly.
Okay.
So
That's really cool.
yeah, and this, it comes with a USB interface chip on it, so you can you just grab any old printer cable, and
Yeah, it's a standard USB-A.
yeah,
USB-B.
and you can plug it right in. The IDE, the interface for it is download and go. I think it works on both Mac and Windows. I've never tried to
So
run
it
it.
isn't plug and play, but it's pretty close. Like you just plug it in, you download the thing, and use that.
And it tells you when to plug everything together, just like any goofy printer that you buy. It tells you when to plug it in, when to
the only
unplug it
thing
and
that
stuff.
you would think you'd need on here is like the next thing I'd want to add, like on an Arduino chip, would be some kind of flash memory, like an SD slot, so you can put like.
Actually, it's
for
interesting
serious
you should
data
mention
collection.
that, because there's information on Instructables how to add SD. They're hacking them out of stuff, or they're buying them new, and it allows you to write to that flash memory, including the flash memory on the chip.
Okay,
So-
because if you had something here where you could write to like a little 8 gig flash memory card,
Mm-hmm.
I mean, for the kind of stuff that's doing 8 gigs of flash memory will last you for years.
Yeah.
So yeah,
This is only
it's-
128 KB of memory.
Yeah,
so-
but if you're doing stuff like sample collection, temperature monitoring,
Mm-hmm. Yeah.
RPM, stuff like that, 8 gigs will let you get a sample a second or a sample every few milliseconds over a huge data curve. So yeah, it's neat.
There's a lot of stuff already made for it. They call it the Arduino this, that, or the other. Temperature sensors, breathalyzer sensors. I'm going to get one because I want to play with one so bad.
That's got to be fun for parties.
there's
That's like college
You
kid.
can find them on YouTube. They've made little tracked robots that got breathalyzers on them, and they'll find somebody that's moving and walk up to them and beep, 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 beep. And they'll tell you what your breathalyzer is, and they'll take off. They'll keep going. So
This is why people invite us to parties. This is me for the magic and you
Roving
for the little
breathalyzer.
breathalyzer robot. That's totally it.
So, and that's at SparkFun. There's a website called
Oh, yeah,
SparkFun,
I'm familiar
and
with
you can
They
buy
should
the
be a
Arduino.
sponsor.
Oh, that'd be so
They
awesome.
should totally be a sponsor. SparkFun, you guys should be a sponsor.
Yeah,
That's
I'd be
awesome.
playing with your toys all the time.
All right, so that pretty much covers it, though. That's
it's
we've
just
got
that
the
simple.
Arduino clock. It's a binary clock. People can find schematics in the show notes on the Geek Group website. The URL is right there. That's where you find the show notes for this. You can get the schematics, you can get the code, you can get everything. You could even be nice and write up a little parts list and where people can get stuff.
Oh yeah, that'd be easy.
You should do that. All right, write it all up. We'll put it in show notes.
Sounds good.
And this is Dan's binary clock.
Yeah.
It's the freaking Eakin binary clock, and you can make one of these at home for like, I don't know, $50.
A little less than that, yeah.
For that much, you could really go and buy a binary clock, but that takes all the fun out of it. So yeah,
It's so much more
why
rewarding when
take
you do
somebody
it
else's
yourself.
binary clock apart when you can make your own? Okay. So thank you, Dan, for coming and playing
You bet.
today. We appreciate you making the trip. And yeah, well, this is neat. You gotta finish this, make me a pretty version, and we'll put it on display in the Geek Group's new labs when we get a lab.
Sounds good.
Cool. You guys have fun. I'm Chris. That's Dan. We'll see you next time. Thank you for watching the Geek Group. Please remember to rate, comment, subscribe. Go to our store right here where you can get this nifty shirt and many other ones just like it. You can look at that. It's a stepper motor, yo. It's the most popular shirt in the store. So you want one.
I do
You
actually.
want- See? You
Yo.
should get one. Okay. So, yes, buy stuff, get involved, donate. We need your help. We want to build Avalon. We want a new lab here in the Grand Rapids area, and you can make it possible. Okay? Share these videos, pimp them out, YouTube, Facebook, all that jazz. You can help. It's people like you that actually make a difference here in the Geek Group. Be a member. Thank you. See you. Bye.
This video was made possible by a grant from the Future Girl Foundation.
This video was made possible by thousands of private donations from members and viewers like you. Please visit thegeekgroup.org for more information on how you can donate and become a part of our dreams of Avalon.